So, up to the last class, anyone having any confusion, any doubt? So, all of you have understood the things that has been discussed after the last class, right?
Yes, sir.
Okay, thank you. So, what we have discussed in the last class, anyone do you recall? So, if you recall, so in the last class, basically, we have basically discussed about the law of gearing, where we have seen like what is the condition that must be fulfilled by gear tooth profiles, okay, so as to maintain a constant angular velocity ratio between the two meeting gears. Okay, there we have seen that particular condition, and we have seen the importance of the pitch point. That also we have seen. Okay, and the deduction of those like how to derive the relationship. Okay, those things we have discussed, and later on we have seen that what we understand by velocity of sliding, or along which direction it is there. Okay, we have seen that basically along the common tangent there is like that sliding velocity that is there, which is given by the sum of the angular velocities, that is the omega 1 plus omega 2 multiplied by the distance between the pitch point and the point of contact. Okay, so it was just like p equal to r omega, so that kind of thing that we have obtained the sliding velocity, and we have understood that there may be some velocity that is the nothing but the sliding velocity along the common tangent direction, but we don't want any relative velocity to be there along the common normal direction, because if that is there, if any relative velocity that is there in between the in the direction of the common normal, then depending on what is the direction, okay, so the two teeth, the two meeting teeth will either tend to separate out, or they will tend to penetrate into each other. Both of the conditions are not desired. So those things we have discussed, and later on we have studied about conjugate teeth. We have said like what we understand by conjugate teeth, and we have also seen the commonly used standard forms of teeth, that is the cycloidal teeth profile as well as the involute teeth profile we have discussed. And I told you to go through in details about these two, and make a comparison and submit. Okay, so I hope you have started studying that, right? Anyone, have you gone through it? Which one is better, involute teeth profile or cycloidal one? Okay, so no one is saying anything. I hope I am still audible. Okay, so today we are going to see what we understand by like path of contact, arc of contact, or what are the relationship between them. Okay, so those things we are going to discuss today. So what we understand by path of contact. So path of contact is remember it's like the what happens basically contact of the two teeth which is there in mass. Okay, it is made where the addendum circle of the wheel, that is the we are talking about the rivet one. Okay, when the addendum circle of the wheel meets the line of action, that is the common tangent to the base circle, that means this is the like common tangent, this is the base circle for this. Okay, and this is the base circle for the other gear, and tangent to both the base circle, this one, this blue direction is the common tangent direction. Okay, so what basically happens when the when the contact gets established, so contact of the two machine gears is made where the addendum circle of the wheel meets the line of action, and where it is broken, where the addendum circle of the pinion, that is the other missing gears, meets the line of action. Now, if you can see in this particular GIF, you'll see there is here at this particular point, this blue point, you can see. So the contact between the two gear teeth that is made here, and up to a certain distance along this particular line, common tangent line, the contact is there, and somewhere here the contact is broken. Okay, so this particular linear distance uh, where the contact was there, for contact gets established here and contact gets broken here. Okay, so this particular linear distance between these 2 points is nothing but we call it as the path of contact. So this is the kind of linear one. Okay, so now there, if you see properly, there are two portions to this particular path of contact. So that we call is the one is the path of approach, the initial portion, and there is the path of resist we call it. So what do we understand by path of approach? It is the portion of the path of contact from the beginning of the engagement to the pitch point. So we also have the pitch point here. So, okay. So first half up to the from the starting of the contact when it is got established up to the, you can say, the pitch point portion. So that is the path of approach, the initial portion. And next the path of recess is there. So this is the portion of the path of contact from the pitch point to the end of engagement. That means whatever the pitch point, okay, the later half up to the end of engagement, that is the path of recess. So as you can see, that means path of approach plus path of recess will give you what? Addition of these two, path of approach plus path of recess equal to what? You can tell me. Hello, am I audible?
Normal path, sir. Maybe.
Huh? Please repeat. This path of approach plus path of recess equal to how much? Equal to the total path of contact? Yes or no? Part of contact had goes to these two part. First up, it is a part of approach plus part of recess. If we add these two up, then we are going to get the part of contact. Okay, the total contact. So this is linear one. Okay. So next we have got
Okay,
the
sir.
arc of contact. So from the name itself, you understand suppose some it is related to some contact between the teeth and some we're talking about the arc length. So now it is the distance traveled by a point on either pitch circle of the two wheels during the period of contact of the pair of teeth. So what is this arc of contact? So if you consider any point on either of the pitch circle of the any of the two fields, okay, so this is the distance traveled by a point which is there on the pitch circle of any of the two wheels, okay, either of the two wheel during the period of contact of a pair of teeth. Okay, so during that whenever the contact was there between the pair of teeth, okay, during that time whatever is the like whatever is the distance travel, okay, distance travel by a point which is there on the pitch circle, then that particular arc distance is known as the arc of contact. Okay, so during the contact time, whatever is the movement of that particular point. So and it is given by arc of contact is given by part of contact divided by cos of phi. So what is this angle phi? Yesterday we have discussed. What is this phi? I have told that this is a very important one. So this is the pressure angle. Okay, so part of contact divided by cos of phi, cos of the pressure angle gives you arc of contact. Okay, and just like in the case of path of contact, we have seen that there are two portions, path of approach plus path of recess, which gives you the total path of contact. So here also we have got arc of approach plus arc of recess, addition of which is going to give you the total arc of contact. Okay, just see yourself, study for yourself, similar to that only. Next, we have got the angle of action. This is not a universal symbol, okay, but sometimes denoted is del, okay. So, but you just write it. Suppose this is the angle of action, write in words, okay. So now this particular angle is nothing but the angle turned by a gear from the beginning of engagement till the end of engagement of a pair of teeth. Okay, so if you consider a particular pair of teeth which is coming in contact, which is going to be engaged, so from the beginning to the end during that particular course, whatever is the angle turned by the gear, that is known as the angle of action. Okay, once again, it has got two parts, that is the angle of approach alpha and angle of recess beta. That means the total angle of action is nothing but the angle of approach plus angle of recess. Okay, so this particular angle will have different values for driving and driven gear. It is important. So depending on what is the size, what is the number of teeth in the driving gear and the driven gear, this angle turned by them, okay, even though a pair of teeth that comes from suppose this one as well as from this one, okay, two ways, okay, so the angle, the value is different for them, okay. because we also know like the velocity ratio that also depends on the size. That means how what is the speed of this and speed of that will be different. Okay, so how much is has rotated, and during that time how much the other has rotated will have different value. Okay, so then we also have got like a pitch angle. Okay, so this is the angle that is subtended by the circular pitch at the center of the pitch circle. So mostly this path of contact, arc of contact, like those will be very important. Pressure angle, etc., is going to be very important when you are going to like solve the problems and all. Similarly, the angle turned by the gear during the course of your engagement and all. Okay, those are also important. Understood? Any confusion up to this much? Let me know. I hope it's clear.
Yes.
Okay, thank you. Now we are going to see how to find out the number of pairs of teeth which are in contact. Also known as this particular thing is known as the contact ratio. It is nothing but the number of pairs of teeth that is in contact. We know that whenever we are thinking of like two meeting gears, okay, and we know all the teeth from both the gears they don't come in contact at the same time. Okay, so if this is gear A, suppose gear A, okay, so gear B, don't mind my drawing, it's a very bad drawing. Okay, so now during this course of your work, okay, your action, okay, so basically there is a certain number of teeth at this particular zone which comes into picture, which comes into contact. So this is basically given, and the knowledge of like how many pairs of teeth are in contact for and for how long. Okay, so that is important. And this number of pairs of teeth which are in contact, it is given by this term contact ratio. We use the word contact ratio for making that like understanding this particular thing. Okay, so now, in theoretically, how we can get that particular value? So this is the angle of action divided by the pitch angle. Then whatever is that particular angle, that is nothing but the that also gives you in terms of the angle. If you know about the angles, then that is the your pitch angle. So contact ratio is we can get by del by gamma. That is this is the part of both the parts are there, alpha plus beta divided by the pitch angle. Okay, it is in terms of the angle. And in general, this is one of the important one. Okay, so number of teeth in contact, that is nothing but the contact ratio generally given by the small n. So this is how we can get the arc of contact divided by the circular pitch. That gives you the number of teeth which is in contact. That is the contact ratio. Now, what is arc of contact? From our previous knowledge, we know arc of contact is nothing but path of contact divided by cos of phi. What is that phi? This is pressure angle, right? So this is the pressure angle, and this is the distance gives you arc of contact. And what is circular pitch? PC. So circular pitch we know. What is circular pitch? So circular pitch is given by pi d by t, and d by t is nothing but it gives you the module, that is scheme. Okay, so what we can write the circular pitch to be equal to pi into the module, pi times the module. Okay, so now that is what we have written. So arc of contact comes from here, that is part of contact divided by cos of pi into the circular pitch. Okay, into 1 by pi m. Okay, so all the tips which is lying in between the arc of contact will be in between the arc of contact will be matching with the teeth of the other wheel. Okay, so within that particular portion of arc of contact which is there, that teeth only comes in contact, that is they will get matched with the other wheel. Okay, so now whenever we are talking about that means now we know suppose there is a particular number of pair of teeth that is in contact, that is a contact ratio that is there. Okay, and now we want that like definitely our we are talking about gear drive, that is a positive type of drive. That means one of the slip is not there, that is different. Okay, apart from that what is our expected thing? So we want that like as we have got like one driver and the driven wheel, okay, so we expect that whenever the driver wheel is rotating, okay, then the driven wheel will get the motion. That is what is the normal expectation. Now we know that that particular motion transfer happens by the gradual engagement of the teeth, okay, messing up that particular teeth from both the mating gears, okay. So now if you're talking about like having continuous transmission of motion from one wheel to the other, then this particular n, that is the contact ratio, okay, it has to be, it must be greater than one, right? It has to be greater than, because if at least a pair of teeth is in contact, then only you can expect that transmission of motion will be there from one wheel to another one. Okay, one wheel means there one gear to another, because the transmission happens to this particular engagement of the teeth only. Okay, if the teeth are not in contact, definitely we cannot expect that any kind of motion transfer will be there. So this n has to be greater than one. Okay. Now we'll see. Suppose what is the meaning of suppose having suppose n value which is in a fraction. Okay, suppose 1 point something or like that. Let's consider n equal to 1.5. Okay, okay, or any value which lies between 1 and 2. Okay. Now what does it state? Basically, if n is in between 1 and 2. Okay, so it states that the number of teeth in contact at anytime will not be less than 1, and it's also never more than 2, so it lies between that. Okay, so if suppose we have this 1.4 1.5 something like that, that kind of value which is definitely lying in between 1 and 2. Okay, so we know that definitely at any time, if you consider at least one pair of teeth is in contact, and as this value is less than 2, so two pairs of teeth is never in contact. Okay, it is not more than 2 at any time. Okay, so now if having any value in between like that, okay, let's consider 1.4 1.5 whatever. So what does it mean? It means that one pair of teeth are always in contact, whereas two pairs of teeth are in contact for 40% of the time. Okay, because see fractional like all the teeth are kind of discrete, like 1 2 3 4, like they are discrete. Okay, and they're kind of no frictional values are there. Okay, even though we are getting frictional values for suppose n. Okay, in actual sense the teeth are like one teeth, two teeth, like that only. Okay, so now if it's kind of 1.4 1.5 or something like that, so it lies between like 1 and 2. So it says that one pair always in contact. Okay, and two pairs also will be contact, but for 40% of the duration of the time. Okay, so now can anyone tell me, if suppose the value of n that you have obtained is 2.3, then what will be the meaning? What is the meaning of that? Who can tell me? What is the meaning of that? Who can tell me the meaning of this? Rishikesh?
Sir, the number of teeth in contact will be more than one, sir.
Definitely more than one. I am talking about 2.3 value. Be specific. One thing is this 2.3, in between which two point numbers it lies, which two whole number.
2 and 3, sir. Between 2 and 3.
Yes, 2 and 3. That means two, like at any time if you consider the number of teeth in contact will not be less than 2. That means minimum two pairs will be there. Okay, and it is not even going to be higher than 3. Okay, so that is the first thing. Now what is the meaning of this fractional value, suppose 2.3? Who can tell me? Rehan?
Sir, the number of teeth in contact will be more than 2 but less than 3, sir.
Definitely, that is the first thing. Okay, first thing is obtained. Now be specific, like with respect to 2.3, because for 2.3, 2.4, 2.5, 2.6, for everyone it will be the same case, na? Not less than 3, not more than 3. Okay, not less than 2, not more than 3. Okay, so now if you sum like 2.3, what is the meaning of 2.3? Rehan, Sisman, Nilutpal, anyone? Try to correlate with the last one, last point. At least try. It is written here itself. Try to correlate with this one and let me know. Okay. If this is the meaning of 1.4, then what about this? If n equal to 2.3, what will be the meaning? Am I audible?
Yes, sir.
Yes, sir. With respect to the last point, you tell me. Read the last point once. Read it aloud.
Sir.
Read it aloud. Read the last point.
Sir, if n is equal to 1.4, one pair of teeth are always in contact, whereas two pairs are of teeth are in contact 40% of the time.
So try to correlate this with 2.3 and value equal to 2.3. And try to correlate with this point and tell me what is the meaning of 2.3 and equal to 2.3. Now if equal to, tell me.
Sir, one pair of teeth will always be in contact. Think, sir.
That is the meaning of 2.3 and equal to 2.3. Anyone else? Anyone? No?
Confused, sir.
Who is confused? Shankar. Now that means, see, I cannot, if you cannot go there, then it will be difficult. 1.4 means one pair is always in contact, and point 4 it means for 40% of the time, two pairs are in contact. 2.3 and equal to 2.3 will mean two pairs are always in contact. Okay, whereas for 30% of the time, three pairs are in contact. Understood?
Yes, sir.
Now, who can tell me if suppose n equal to 2.5, what will be the meaning? N equal to 2.5, what is the meaning?
Sir, two pairs in contact 50% of the time.
That is the meaning of 2.5, n equal to 2.5. Anyone else? Shankar?
Yes, sir.
Yes, what will be the meaning of 2.5 then? N equal to 2.5.
Sir, the 2 points will be always in contact.
And what? হেল্ল', মই ক্লাছ লৈ আছোঁ ৰ'ব। কিবা ইম্পৰ্টেণ্ট আছিলে নেকি কওকচোন? অঁ 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 এজন পঠাও বুলি ক'লে বিক্ৰম ছাৰত মই তাৰপিছত অফ কৰিলোঁ। কওকচোন বাৰু কি ক'লে ফাইনেলি? অঁ নাই মই থাকিম, মই অভাৰচি কৰিম ডেফিনেটলি, মানে মানুহ থাকিব লাগিব সিহঁতৰ, সেইটোৱে কথা। অঁ হুম 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 ছাৰ্ভিচ ইঞ্জিনিয়াৰ এজন দিব ন? তাকৈ পঠাব। মুঠবা সেইদিনা আপুনি টাইমিং কৈ দিছে নহয় ফাৰ্ষ্ট হাফত হেৰিত বুলি ৰাতিপুৱা? ঠিক আছে বাৰু। অ'কে থেংক ইউ। আৰু তাক কণ্টেক্ট কৰি থকাৰ প্ৰয়োজন নাই আৰু মই পিনাকীক? আপোনাক কিবা নাম্বাৰ চাম্বাৰ দিছে নেকি যোন আহিব? দিব বুলি কৈছে ন? আপোনাক দিলে আপুনি মোক আৰু বিক্ৰমজিত ছাৰ দুইজনকে দি দিব। অ'কে। Okay, so yes, I just got a call from university side that is regarding some NAC visit. Sorry for that. So yes, 2.5 means. So
Sir, in 2.5, two pair of teeth will be always in contact, whereas three pairs are will be in contact 40%.
not 40%, 50%. Three pairs, 2.5,
So,
no,
So it's no.
2.5.
yes, sir.
Two
Yes,
pairs
sir,
will be
2.5.
always in contact 100% of the time, and 0.5 means it is in between 2 and 3, right? So three pairs will
Yes,
be in
sir.
contact for 50% of the time. That 2.5, na. Had it been 2.4, then three pairs will be in contact for 40% of the time. Understood? Is it clear now, others?
Yes, sir.
Yes, sir.
Okay, okay. So next, the topic that we are going to see is slides are visible, right? The slides
Sure.
are visible, right?
Yes,
Yes,
sir.
sir.
Okay. Okay. So now interference in involute gears. Okay. So now sometimes what happens, there is a phenomenon known as the interference, which is actually not a desired one. Okay. And we must try to avoid the interference. So as we have previously seen, if you recall, then previously whenever we have said about like cycloidal profile and involute profile, out of that we have said that because of ease of standardization and manufacturing and low cost of production, it is a kind of better choice, right? Invalid profile is better choice, but there is one problem with that. So that is the sometimes in the invalid gears, if you don't design it properly, there may be a problem. There may interference might happen. That is the one of the problem. Okay, so basically, interference means what? Actually, as you can see in this particular figure, so basically you can see the root portion from one mating gear is trying to dig out in the flank portion or in the root portion of that particular on gear. Okay, so if this figure is visible to you properly, then what may happen, you can see in this particular person some interfering is happening. So this teeth, okay, is trying to dig out material from this particular teeth. Okay, it is trying to go inside here. Okay, nutrition. So if that is happening, that happens, then there will be problem of like one is like wearing out of tooth material from here. Next is sometimes some material will be digged out from here. Another problem which might happen is like it may deform that particular teeth profile itself. So if any of this particular thing happen, then the efficiency of the drive will decrease, or sometimes even the teeth of the gear may also break. So if those are the problems that if that is going to happen, then the whole drive will be actually a kind of failure. Okay, so actually for that to it for we don't want any interference in that particular case. Okay, so now what happens like and for that actually one particular case is there, like we can go for undercutting. Undercutting means removal of, if you look at this particular second figure, the right hand side one, okay, you will see, just do it, mouse is not working. what happened? So now basically meeting of two non-conjugate non-involute teeth is known as interference because the two teeth actually they do not slide properly and what happens some rough action and binding occurs in between. So this owing to this non-involute profile what basically happens the contacted teeth that have different velocities which can even lock the two gears if there is a problem that is happening. So if it locking is happening then there will be problem because one of the the drive is trying to rotate but it has got locked so there will be different problems like the thrust problem some axial thrust it may be there okay unbalancing it might happen all those different problems might happen and if that interference is there due to the interference the tip portion of the pinion it try to dig out the flank of the tooth of the gear wheel as you have seen in this particular figure. So if you look at this particular tooth upper one okay from the gear and from the pinion. So now here at this particular person the tooth person as you can see here the interference person so tooth person is trying to dig out material from the other and these are not desired as we have already said the tooth may be weakened by the removal of material from its root okay but if we solve the problem by undercutting the gears then there is actually no interference that is going to occur if the gear meshes with the undercut portion. So here in the second figure you can see so portion okay so in this undercut portion is there and as this height has been decreased here so during that case no rough action will be there so it will not try to penetrate inside okay because undercutting is there which is nothing but a kind of removal of material from here and some smooth action will be there okay and basically depending on the relative position between the addendum and base circle whether it is being below or above each other it actually also depends on the number of teeth what is the pressure angle what is the module etc etc. Now by this time we have understood that basically this interference in involute gear it is a kind of problem and that is not desired okay. So now to avoid this interference as much as possible some of the methods you can you can try some of the methods like one is you can do you can decrease the pressure angle not decrease sorry you can increase the pressure angle by somewhat okay and that may lead to some decrease in the interference problem and that's why in general as I have if you recall one of the class I told you like previously 14.5 degree that pressure angle was we have been using that okay 14.5 degree and nowadays it is somewhat actually like 20 degree 25 degree those are the kind of standard pressure angle value we generally go for nowadays okay as you can see there is a slight increase in the value of pressure angle and this is one of the reason because increasing this pressure angle we have seen that we have got certain advantage in terms of decrease of your interference okay if we are doing that apart from that as you can see the actually this tip portion of the tooth only tries to dig out the material the interference is because of that so that's why what we can do the height of the tooth it might be somewhat reduced okay if that is done then also the interference problem can be somewhat avoided okay and the addendum circles of the two meeting gears gear 1 and gear 2 from which the teeth are going to meet okay it should be adjusted in such a way that they must intersect the common tangent to the base circles between the point of tangency here okay here in this particular figure you'll see here okay in the third figure oh, okay understood. So then for today we'll stop here. In the next class we'll see suppose there is definitely a requirement of having a certain number of teeth in that particular wheel also. Okay, to avoid the interference because that is also dependent on suppose how many minimum teeth that is there in the gears. Okay, that is also there. You cannot like arbitrarily do anything. Okay, arbitrarily design it like that. So in the next class we'll see we'll try to solve problem also and we'll see how that's the kind of how to find out the minimum number of teeth to avoid interference what you understand by interchangeability of gears okay and after that we'll try to solve some problem okay so for today we'll stop here if you have any questions you can ask. If no, we'll respond to your name calls. Nilutpal. Nilutpal. Seems like he's just joined but actually not active. Shankar.
Yes, sir.
Arshisman. Arshisman. Absent. Rehan. Absent. Partho.
Present, sir.
Rishikesh.
Present, sir.
Chermiki.
Sir, sir, Nilupal sir, present, sir.
Nahosal.
Yes, sir.
Teza.
Present, sir.
Rishikesh Nath.
Yes, sir.
And Emil.
Sir?
Emil absent, right?
Sir?
Okay, so yes, Nilutpal, where have you been? I have been
I was
calling
here
your
only
names.
listening to someone. Yes, sir. Someone was calling me from back, so I was not able to listen you, sir, properly.
Someone was calling you from back. You are in class or
I
what?
mean, I'm in class, but in my home, someone was calling me, so I
Okay,
couldn't listen, sir.
receiving your attendance. Okay. Okay, so thank you everyone.
Thank you, sir.